Hello everyone, and welcome to the AI on Demand webinar series, AI Innovation from Research to Market. My name is Loredana Bucșeneanu. I'm a member of the AI on Demand team, and I'm happy to be your host for today's session. So for those of you who are not familiar with AI on Demand yet, it is a community-driven platform designed to empower European AI research and innovation ecosystem by providing a series of quality resources such as data and AI experimentation tools, but also training and learning resources, information about events and funding opportunities. So as part of the objectives of AI on Demand, this webinar series aims to showcase AI innovations developed in the research environment that demonstrate real-world application. So the series brings together research and industry, highlighting AI tools and services that support businesses and developers to advance their AI-driven solution. So like you know, today's session focuses on tackling disinformation with cutting-edge innovation. So we see more and more in today's very rapidly evolving digital landscape that false information is spreading faster than ever, and it poses a serious risk to our democracy, society, and economy. So tackling these challenges now more critical than ever. So I'm happy to present the three experts that will guide us through today's discussion and that work together on the vera.ai initiative focused on disinformation analysis and AI-supported verification tools and services. So they are Olga Papadopoulou from ITI CERT, Martin Heiben from Kinit, and Luca Cucovilo from Fraunhofer Institute for Digital Media Technology. So welcome. And just before passing the floor to Olga, please know that we will have a Q&A session at the end. So feel free to add your questions in the chat in the meantime. So Olga, you have the floor.
Great, thank you, Loredana. Can you please confirm that you see my screen?
Yes.
Great, thank you. So, hi everyone. I'm really happy to be here today and to present the vera.ai assets uploaded, integrated into the AI on Demand platform. As Loredana mentioned, I will start the presentation, and in collaboration with my colleagues Martin and Luca, we will present the vera.ai assets. I will start. I will start the presentation with a brief overview of the vera.ai project, then delve into the problem of disinformation, and at the end we will present the AI on Demand vera.ai assets. With respect to Vera project, this is a Horizon Europe project which brings together 14 partners over EU, both research partners, universities, as well as companies and civil society organizations, and most importantly, journalistic media organizations. What we are trying to do is to come together and bring trustworthy AI solutions with the goal of fighting disinformation. We try to bring these tools to the hands of media professionals, journalists, and fact-checkers. And Vera can be said that it is a quite ambitious project, which try to bring a wide range of solutions, but also performs computational social science research around this information. Vera AI objectives are built upon 4 pillars. The first two objectives around content are specifically to build AI methods for content analysis, enhancement, and evidence retrieval, and also methods for detection of deepfake, synthetic media, and manipulated content. With respect to disinformation spread, discovery, tracking, and impact measurement of disinformation narratives and campaigns is investigated. towards human AI, intelligent verification and debunking authoring assistant, which is based on chatbot NLP technology, is built in order to provide explanations on the AI outputs to the users, to the verification professionals, and also to guide them how they can use the verification components in the verification flow. In addition, a fact checker in a looped approach is used in order to gather feedback from the users, which is used as a side effect of verification. And last but not least, adoption and sustainability of the new AI tools in real-world application through the integration in leading verification tools and AI platforms. And one of these platforms that we are taking into consideration is the AI on-demand platform, which we are discussing today. So the methods that we are building are based on cutting-edge AI research, but from the research lab to the actual users of these tools, there is a lot of effort to be spent. Within Vera project, we have 3 user-facing tools: the verification plugin, which is a browser extension with more than 100,000 users. Truly Media, which is a commercial platform, and a database of non-fakes. Within the project, we try to build to integrate the components, the individual tools that we are developing based on this research into this user-facing tool. However, in addition, we disseminate our results in relevant communities and platforms such as Edmo Hubs, and we also have synergies with other projects. In particular, we are part of the AI-based disinformation cluster, which is a cooperation of 6 European Commission co-funded research projects, which include research on AI methods for countering online disinformation. The projects which are part of this cluster are Vera, AI for Trust, Titan, AI for Media, AI Code, and AI for Debunk. And for more details, there is a dedicated webpage in Edmo website, which presents these projects and highlights the activities that have been done and some future plans that we have as cluster. So moving on to the problem of disinformation, what worth mentioning is that even though disinformation has been recognized as an important problem even since 2016, the latest World Economic Forum Global Risk report has ranked disinformation as top global risk for the next 2 years and the fifth for the next 10 years. This indicates that disinformation is still a pressing concern and that we need to develop tools that can combat disinformation. A link of the report is provided in the minutes for more details, but I can note that this report was obtained from insights from 900 experts across academia, business, government, international organization, and civil society. With respect to synthetic media, we all know that they are taking over the internet. Synthetic content affects all kinds of media, so from simple text to news articles, synthetic audio, images, videos. And we have seen that during the past years, a growing number of cases where the synthetic media has been used in either propaganda or political disinformation, but in any case, in several malicious, with malicious purposes posts. Here are some examples per modality. So an example of an image, a generated image, is the well-known example of the Palestinian man carrying his children out of the rumble. This image went viral with huge engagement through online social platforms, but this image was generated using artificial intelligence. Another example, for example, for video, this Indian politician used AI to translate his speech into other languages, and the purpose was to gain more voters. And he This video was have been seen by several million viewers, users into India. So we can see where this indicates how huge impact this Gen AI media can have. Another very interesting research is research from Google DeepMind and Ring researchers, where they have investigated and analyzed 200 cases of Gen AI misuse, and they presented a taxonomy of them. What was mentioned is among the most common cases that malicious users use, the most common tactics that they use to deceive people is impersonation, scaling and amplification, and messaging falsification. These are used heavily related to disinformation campaigns and propaganda. And another analysis that is interesting from this research is that they presented how frequently each modality has been used in these cases. And although images are the most used one, it seems that also text, audio, and video are heavily used. For that reason, it is obvious that we need powerful tools for combating disinformation. And last, before we move to the assets, I also would like to present a survey from which we have, with the help of our partners in vera.ai project, AFP. They conducted an analysis of existing fact-check deepfake cases, and they found that a large percentage of that cases aim at spreading political propaganda, war propaganda, political disinformation, health disinformation, and other harmful content, which also indicates how disinformation is important and how combating disinformation is also more important. So now we will move on to present the assets that the vera.ai assets that we have integrated in AI on demand platform. So currently we have 12 assets, including 6 datasets, 1 service, and 5 ML models. Here is the page of vera.ai in the AI on demand platform. Before moving to the details, I would like to mention that we are at the end of the project, so our project ends September with maybe a small extension. So we currently have some more mature tools, and we will definitely consider to integrate more on the AI on demand platform. I will now give the floor to my colleague Martin, who will present the text-based assets. Just Martin, to mention that I'm not seeing you, so please, for changing slides, let me know.
Okay, thank you very much. Okay, so within the vera.ai project, our institute is focusing on textual-based content or textual content itself. And within the process of fact-checking, we are trying to create tools that help the fact-checkers to analyze the text in order for them to be able to decide on its veracity. So let's talk about the textual content. So the smallest unit of the information that the fact-checkers are working with are basically claims. And in their work, journalists and professionals and fact-checkers probably encounter a lot of information, a lot of claims that needs to be decided and to process, and to basically decide which claims are relevant and are really worth of checking. We have defined the task to identify the claims that are check-worthy, or the term is check-worthy claims. And for this purpose, we defined the categories, or within our task, we defined the categories of check-worthiness and non-check-worthiness. And basically, you can look at these categories as some sort of questions that we need to ask in order to decide whether this claim that we are assessing is really important, that has is significant or has some impact on also is it really check worthy and worthy of the time of the fact checker in order to verify these claims. And so you can see the table below that contains these categories. You can see that we are looking at the significance, controversy, impact, and source reliability in terms of checkworthiness. And in case of non-checkworthy claims, we are talking about subjectivity, triviality, or common knowledge. So if the claim is, for example, significant or has some impact on society, then we consider that it as check worthy, and if it's subjective and trivial, we consider it as non-check worthy. So let's have some small example. For example, we have a claim that says a new study suggests that drinking bleach can effectively cure COVID-19. We encountered this type of claims a lot in the data. So if we consider our categories here, this claim is definitely significant and controversial, and definitely has the impact on society. So we can say that there is definitely a case here, and in case that the source of this claim is reliable, we can definitely decide that this claim is check-worthy. Let's have another example. So, for example, in my opinion, a COVID-19 pandemic was fake. So this is a clearly subjective claim, because there is this part that, in my opinion, which is basically talking to or referring to subjective opinion, and this definitely impacts the checkworthiness estimation. So you can see that here the claim is considered non-checkworthy. Let's get to another example, but let's take into account that, for example, this claim was or was presented by some very important figure. So, for example, President of USA. But so now you can see that the source of this claim makes the things different. You can see that this claim would be significant even though the claim itself contains subjectivity. So you can see that the task of determining whether the claim is checkworthy or not checkworthy is not very trivial, and therefore we are preparing tools that will help professionals to determine whether these claims are actually, and filter a lot of claims that are checkworthy or look like checkworthy from the perspective of our tools. And for this purpose, we need to collect a lot of samples to be trained by some model or some neural network models, and it should generalize across multiple domains. In this case, we need to collect the claims that contains a lot of languages, especially those that are most frequently used by media professionals like fact checkers or journalists. So, for example, these days, the most important languages are basically Russian and Ukrainian, but in the past these languages were different. So if we collect as many languages as we can provide more robust models. We also focus on as diverse topics as possible, especially those that are most impactful in terms of social implications. So politics is definitely number one, but also there might be topics like entertainment or sports that might impact actually the Chegworthy claim estimation. And also the last, or one of the one that we are considering, the last factor or domain here is writing style. So based on the source of the claims, we consider the structured writing style of the article of the text, which can be found, for example, in news articles. But we also consider a noisy writing style that is mostly can be found in social medias or in text that was produced by non-professionals, but just common people. Let's go to another slide. So in the terms of vera.ai, we created the dataset that we called the general claim dataset that contains more than 400,000 samples in 10 languages, 6 topics, and 2 writing styles. And we prepared or trained the models on the top of this dataset that allow users of these models to do the estimation of Chegworthy claims detection. But as you can see, even though there is quite a huge number of samples in this data set and quite a lot of languages, it's not really balanced. You can see clearly that English plays the main role in this data set because it's obviously the language that is most used on the internet and also by the professionals or people who are actually creating news and etc. So our aim is to create a much better data set, much more balanced data set that we are currently working on. So the first, I would like to say that the general data set is already a part of AI for Europe domain. So it is available at the moment. But currently we are working on the improved version of this dataset, which is called multi-CW dataset or multi-Chegworthy dataset. We have to say that it contains a little less samples than the previous one, but it contains much more languages, 16 languages to be specific, 6 topics and 2 writing styles. And it's very balanced. We are working hard to make it as balanced as possible to ensure the highest quality of Chegworthiness estimation. So this data set is being created at the moment in our institute, and we are training the models on this data set. And these models will be uploaded once we have finished this training to improve the current versions of the models. Let's go to another slide, please. Yeah, and the models that are trained on the data set are like, there are two groups of models. We can basically use the fine-tuned language models. Especially we have chosen 3 models that are listed, so MD-Berta, XLM Roberta, and LESA model. These 3 models are widely available domains or models in the research community. And we are doing this fine-tuning process where we basically take the model which is already trained to understand the language in multiple languages, and we are fine-tuning it for this specific task of Chegworthiness detection. And we are comparing these 3 already fine-tuned language models on our dataset with variety of large language models that are available One example would be ChatGPT, but there are a lot of other models that are available. But these large language models are used or are compared with these fine-tuned language models without any change. So it's called zero-shot prompting. So we do not give large language models any previous information about the task, and we compare these large language models with the models that have been fine-tuned for the task. And we did a benchmark with our general claim dataset that resulted in knowledge that the fine-tuned language models still outperform large language models at the time. We are going to, of course, repeat this benchmark with the new version of our dataset, as well as large language models currently have went a lot or a long way since we did last benchmark. So basically, we are really curious about the results that are more recent. Let's go to another slide. Yeah, and one last thing that I would like to mention is that the models that we prepared are available via our tool that is called Central Claim Extractor, which is available like for the public. And this tool is also a part of AI for Europe domain, so it is available, and it contains the 2 out of 3 models that I already mentioned, and it can be used for checkworthiness claims detection. So it works in a way that there is the input text that should be provided by the user. User can choose which model should be used, and this tool can basically split the text into the sentences and classify each sentence whether it contains the checkworthy claim or not. And that's the first step. And what it can do afterwards, also on demand, this tool can also extract the central claim, so single central claim of all checkworthy claims detected in the previous step. And basically, it summarizes all the claims that were considered or classified as checkworthy, and will create or summarize a single central claim of the text that was input or what was put as an input by the user. And so, of course, once our models or most recent models are trained, and we already know that they are much more accurate than the ones that are currently there, we will be, of course, updating our Central Claim Extractor tool with the newest models, and we will upload those models into the AI for Europe web platform. Yeah, and that's basically all from me. Thank you very much.
Great, Martin. Thank you very much. So now we continue with the image-based assets. What we currently have integrated into the AI on demand platform is a method for image forgery analysis and a method for synthetic image detection. Starting with the image forgery analysis, the method is called OMG Fuser. It detects and analyzes manipulated or falsified images to determine their authenticity. What is this? It can be identifying alternations such as copy move forgery, splices, and retouching. With respect to the method, what very briefly do is that analyzes and fuses an arbitrary number of forensic signals. It unifies feature level and score level fusion, and it captures image semantics using any large-scale pre-trained instance segmentation model. And all this concluded in a state-of-the-art performance in image forgery detection and localization. This tool is integrated into the verification plugin as part of vera.ai project, and I will present you an example, the image that is in the slide. I will demo it through the plugin. After, I will first present also the synthetic image detection tool. So this tool, this model, which is called RHINE, tries to detect if an image is synthetic, so it is generated using AI technology. Very briefly, with respect to the RHINE model, it leverages low-level visual information from intermediate transformer blocks because our analysis showed that this visual information contributes to the performance and also to the generalizability of the model. It learns a forgery-aware vector space on top of clip image representations. And what we observed is that training on pro-GAN data, the evaluation on GAN and diffusion-based models, images, suppresses state-of-the-art performance, which indicates that it provides a generalizability. I will now stop sharing and as I said earlier, in vera.ai we have three user-facing tools in which we integrate the individual components, and this tool is the one that is provided to the users, and the users can use our tools through this plugin. The forensics tool, which is the first I presented, is here. So taking this example, as I presented, oh, sorry. Okay, what I done. So copying a link of an image here and clicking the Analyze button, it returns some results. There are several filters, several forensics models that are integrated into this tool, but the one that we presented here, and it is integrated into the AI on demand platform, is the OMG Fusion, which detects forgery with 80%. And it returns this filter, this map, which if we open it, we can see that it detects that this flag is inserted into the image and it's not part of the image. So this image is manipulated. The original image is exactly what you are seeing, but the flag was inserted afterwards in the image by intending to manipulate the image. To give some context, this image is a pretty old image. It is from the Catalan referendum, where the crowd and the police was in attack, and this flag was inserted, and this image was posted through via Twitter and engaged a lot of views and reposts because adding this flag made more provided more sense to this image. The image without the flag didn't obtain any views and shares, or at least not the large number that the manipulated image collected. So there are more filters, forensic algorithms, as I said, because this traditional manipulation is pretty difficult to detect with just one algorithm. Although these deep learning algorithms, which are latest advanced methods that we have developed, can generalize better than the previous models. Then I would like to also show an example for synthetic media. This is a synthetic image. Okay, I understand that everyone can inspect this image and be sure that it is synthetic by the content, but just want to show how this tool works. So again, you copy paste the URL of the image and you have a result like that, which says that the AI generated image is detected. It also presents how likely the image is to be AI generated based on the models that we are using. Again, for this tool, we have several models. So the one that is integrated into the AI on demand platform is in the wild RHINE model. We also have developed some more models which will be integrated into the AI on demand platform in the near future, since they were still in experimental phase when we integrated the RAIN model. This is another example which we can say that it is more realistic than the previous one that I show. It is the example that I mentioned in the presentation, which was spread online and gained a lot of engagement. And again, pasting this image and inspecting the result, it seems that the tool detected this image again as AI-generated image. Using this tool, it is pretty easy to have an estimation of whether the image is synthetic or not. However, I need to point here that, of course, these tools are built based on technologies, based on training data, so they cannot be 100% accurate, and the need of a user to inspect the results is mandatory. And these are the two image-based assets that we have uploaded on the AI on Demand platform. And now I will give the floor to Luca, who will present to you the audio-based assets.
Thank you, Olga. So for what concerns the audio, we decided to focus on the data sets because audio is always kind of tricky in the sense that, especially for disinformation detection, we have to deal with speech, which is person-related information, which means that to create a data set, you need to be aware that there are some constraints from the GDPR and some regulation that needs to be followed. And also same story counts for music and for copyrights. So what we did was we tried to release data set that we based on content that we checked in advance, so that then follow-up versions of these data sets can have a good start, a good basis to start from. And also they all have a commercial friendly license, so that this can also be used for any sort of purposes as long as there is a citation to them. So the first one, which I would like to tell you about, is the dataset on synthetic speech. And for this dataset, what we did was we tried to focus on the biggest requirement out there, which is generalizability. So there are datasets available for synthetic speech detection. However, they all had some problems due to some unexpected biases that appear. And due to those biases, whenever you train networks on that data, then you end up having problems as soon as you apply them to something else. So there are signs that the network for synthetic speech detection, for instance, focus much on silent parts, which we had to remove, or that they learn that if there is a gender imbalance, then they learn that female examples are the ones which are more likely to be synthetic. So we tried to get rid of these troubles, and we did it using as real data the data which we checked for GDPR compliance in advance. We did this for English, German, and Spanish because they are widely used, especially in the in the central part of Europe. And what we did was also, in order, again, to avoid any bias, what we did was that we generated sentences so that each sentence is present only for one speaker. And for that speaker and that sentence, you have an example with natural content and then several examples with synthetic content. So, and the idea is, again, to avoid that the networks learn that some sentences are more likely to be synthetic or natural than others. With the focus is to have a strong basis, to have a tool which can generalize properly, and also to set, let's say, a kind of workflow that you can expand over time. So there is going to be a new release of these data sets, including also commercial tools. The current one use open available data sets, so openly available models that we train ourselves to generate the synthesis. All the content is uncompressed here with the idea that it's possible to apply encoding or background noise and so forth afterwards to challenge more the detector and also to have more variety in the training data. However, this is not an unimportant detail, because we've seen during the course of the project that encoding might have a very strong impact. So whenever there are several versions of the same file which have been re-encoded over and over, the one that gives you more reliable results is the initial one, the one for which there was no encoding, or as least as possible. And this is the reason why we also released a second dataset, which is the one on audiophylogeny, which helps supporting this sort of operation of investigating what is a root of a set of files. So the example is to the right. We start from a set of files that we define as being near duplicate, in the sense that let's say a human listener will be able to tell, okay, this is exactly the same content. It might sound slightly different. There might be background noises. There could be different qualities, but whenever a human listens to that, can tell that it's the same, but then can't really tell which was the original. So this is the operation that this dataset tried to support. And this is an operation for which, to our knowledge, there were absolutely no datasets available. So we put it as a basis for others to train and then to evaluate their own algorithms for this. And we hence created two different types of trees, which are this the structure at the bottom, in which you can identify the original and then all the childs. The first type is including ASC and MP3 encoding, fading and trimming. These were the transformations that have been used in previous works on audiophylogeny. But we also created an extended version, which is meant to mimic the case in which you want to try to avoid recognition by automatic matching algorithms used, for instance, for copyright detection. That will be pitch shifting and time stretching, even though with a moderate amount, so that it's not obvious that the file was heavily modified. But if you think about the disinformation detection, actually, these files which are used for disinformation do not normally come only from one source. They come from several, which get mixed together. And to reflect this kind of data set, we created a new one, which is meant to address the audio provenance analysis. This is a more complicated scenario that you see on the right, in which you start from a set of files about which you have no information. And what you do is you group them together in colors for these slides into sets of near duplicates, but you also find the partial matching. So if you find that a portion of a file has been reused in a second, you can draw, in this case, dashed arrow to tell that that file was partially reused to create a new tree of content. This again is something which can be reused to figure out if there are interconnections between different groups who are sharing related material. It can be found to detect coordination. And the idea is to help methods that are normally based on text by having this sort of input as additional information for coordination. Also here, we had to start again from scratch because there were no data set available. And we made two scenarios here that we think represent what can happen. The first is the case in which a single original file is split in chunks and then is concatenated with some music or with its own content. For instance, if you think about a synthesis of an event or like some commentary about what something has that happened. The second scenario, the multi-source, is instead mimicking a more malicious case because there are two sources of interest which were concatenated, but there is also background noise with the idea that you try to avoid detection of cuts and in general to confuse all these algorithms that either look for content or that look for content manipulation. So that will be everything for the audio. I think I have now to leave the floor again to Olga.
Thank you, Luca. So now we will move to video-based assets. The asset that we have integrated into the AI on-demand platform is the keyframe selection and enhancement service. What this tool do is it is designed to verify video authenticity by providing a clear and concise visual summary of its content. It actually isolates critical visual elements such as faces and text and enhance them to facilitate reliable media verification. It can support experts in quickly recognizing and countering deceptive narratives. And how does it do this? It takes as an input a video. It fragments this video into shots and subshots. Then it extracts a set of representative keyframes from each fragment. On these fragments, it detects faces and text regions. It groups the same key elements in the same shot. And then at the end, it selects a representative from each group of key elements and generates an enhanced version of each representative element. So, for example, looking at a video that was shared by a number of far-right and individual accounts claiming that an illegal immigrant gets violent against a woman in a German subway station in June 2024, inserting the link to the service, it is also integrated into the verification plugin that I presented earlier, the other two tools. In terms of time, I will not demonstrate it live now, but I will explain the context. So, adding this video into the tool, it segments the shots and it presents the most the representative ones. So the user can take one of these shots, which to his knowledge seems more clean and good. It can apply reverse image search on this keyframe, and based on the results that Google or other machine reverse or other search engines returns, it can detect any clues that will that can define whether this video claim, whether the claim of this video is true or not. And specifically for this video, the keyframes that are returned are shown in the slide, and applying reverse image search of that frame, the last one, which presents the face of this man that the video indicates it is an illegal immigrant in German. It returns several posts that discuss about this man, and actually there are a lot of posts that indicates that this video was taken in Spain. It's not in German, and actually this video, although the query one was shared in June 2024, we can find this video already shared in February 24, so a couple of months earlier, which indicates that the video that was shared with the claim of the illegal immigrant attacking a woman in a German subway station is not correct and real. Also, I would like to mention that this fake claim with the viral video obtained 2 million views, which indicates how impactful false information can be. And then moving from video-based assets to multimodal-based assets. In this challenge, we have built two data sets. One for image text verification, which is called Verite, and another one for evidence verification called Credul. The first dataset, which is for image text verification, we sourced reputable fact-checking organizations, specifically Snopes and Reuters, to collect the articles. The aim of this dataset is to evaluate detection models for image text pairs, including three classes. True, which is for pristine information, out of context, and miscaptioned. So with miscaptioned, we mean images and videos where the images and text, where the text itself is false information. However, out of context, on the other side, is images and video and text where the text is not false, but it doesn't have any relation with the image. So both elements are true, are reliable, but there is no connection between them. The goal of this dataset was actually to mitigate unimodal bias. What we observed is that text-only models could compete and even outperform multimodal models on a supposedly multimodal task. And in order to overcome this bias, we tried to collect this dataset of mitigating unimodal bias. In the data collection process, what we have done is we avoided asymmetric multimodal miscaption, which means that a false textual claim that is not related to an image is not included. And an image that has nothing to do with the claim is also not included. And what we employed is modality balancing. So each image in the dataset is matched with both a true and a false claim. Therefore, a model cannot reach high performance just by considering a single modality, and with this procedure, we mitigate the unimodal bias. The other dataset that we have collected, the Credul one, is for evidence verification. It is an automated fact-checking pipeline where we retrieve evidence from the web. So for a claim, we call online platforms in order to collect evidences and to detect which of these evidences are credible, unreliable, and leaked. So we split the dataset into these three categories. The dataset contains a large number of articles, and it also, in addition, contains domain credibility scores, which were collected by media bias fact-checking website. The challenge in this dataset was to ensure the exclusion of unreliable sources and leaked evidences when training early detection models, because collecting evidences might be helpful for the verification process, but if we collect unreliable or leak evidence, it may corrupt the results. So the main challenge was to exclude these unreliable sources. And that is for the multimodal based assets that we have uploaded into the AI on demand platform. And before closing, I would like to mention that since we are approaching the end of Vera project and we have mature results from what are derived from the research conducted within the Vera project, we are organizing 2 half-day sessions on June, one on 17 and one on the 24th of June. The first one is dedicated to end users, practitioners, where we will present how the user-facing tools are addressing disinformation. And the second session will be directed primarily at the research community. So we will present the research behind the tools, how we build the models, how we train the models that detects the false information, the malicious content. For more details of the event, and if you want to register, you can visit the site, which is included in the slide via the QR code. Thank you very much. I will give again the floor to Loredana.
Thank you so much, Olga, and also to Martin and Luca. It was very interesting to learn about the data that you shared at the beginning, to see how much impact disinformation already has in our society. So I would like to leave some space now for Q&A. If there are any questions from the audience, please add them in the chat. And maybe to break the ice, I can have my own question first. So I wanted to ask you, since these disinformation tactics are constantly evolving, how does Vera AI project stay ahead of these threats? And what role the collaboration with fact checkers, with journalists or other stakeholders has? Because I've seen you mentioned that you work with these kind of partners in the community as well.
Thank you, Loredana. So, yes, I think that the most important part in our project is our collaboration with actual users. We have partners from AFP and Deutsche Welle into the Vera project, which are actually using these tools, not exactly those that we are collaborating, but their colleagues are using the tools in their actual workflow for verifying content. We also have a partnership with in the project with EU Disinfo, which is an organization that also uses the tools actually in real cases. And how we are ahead of emerging threats, we are collecting feedback from all users. The verification plugin that I presented earlier has more than 100,000 users. So any new items that are submitted there are used as reference for us to improve the performance of our tools to stay ahead of emerging topics. And in any case, from a research part of view, we are also investigating the latest methods that are released and the more advanced technologies that are published. I don't know if Luca and Martin would like to add something.
Maybe I would add that what we are doing is also trying to get out of this loop of catching up to the latest synthesis detection, so synthesis creation method, but rather try to focus tools that learn how natural content should work and look like, so that even if the technology around it is evolving, you don't need to necessarily retrain the model each and every time, but they have a strong basis start from. Sometimes you might need to update it, but it should not be on a daily basis. Otherwise, of course, they just cannot be used.
Indeed. We have two more questions for now. One is from George. They ask if you consider that your tools can be used for citizen fact-checking as well, not only for media professionals.
Well, maybe I can answer this. Well, definitely our tools are made also for public, although they are most focused on journalism professionals, but definitely they can be used also for public.
Okay, and I think the example that you shared earlier, Olga, it shows that it can be really used by anyone.
That is one of the nice part of working with directly with the journalists, because we are also getting feedback on the UI and on the how much intuitive they are and what are the pain points in understanding the output. So it's a continuous collaboration between the two sides, like research, journalists, and then UI design.
Critical collaboration, I would say. So the next question comes from Philip. So about what are the biggest technical or ethical challenges that you've encountered during the development of these tools, and how do you address concerns around biases, transparency, and potential misuse? In particular, how you deal with them in text verification.
Okay, so yeah, the bias in the textual data is a very, very big challenge. Therefore, we are focusing on so-called fact-checking articles. Our data set is composed mainly of this source of information. It's basically the articles that were produced by fact-checkers and should be as reliable as possible. But of course, even in this source, there can always be some sort of bias included or introduced. So we always try to analyze our data like before we use them. So yes, this is definitely a big problem that we are trying to mitigate.
And a final question from Davide is that you consider releasing an app like a hub where user can download and install on their smartphone, sorry.
Well, we don't have something like that in our plans. It's a good suggestion because nowadays everyone is using smartphones and apps is a very easy way to use something. However, we have the browser application, the verification plugin, which is accessible through most browsers, if I can also say from all browsers, but I don't want to say all because I'm not sure. And everyone can download it from the respective extensions store of each browser and use it through the phone, not as an app, but as a web application.
All right, great. So indeed, there's potential for that. All right, so as we wrap this session, I want to sincerely thank you, the speakers, for your valuable insights and the contributions, and of course to the audience for their participation. So I hope you find this discussion interesting, inspiring, valuable. So if you enjoyed the session, I encourage you to visit AI On Demand's website to explore more assets that exist there, including, like you've just heard, those from vera.ai project. And you can also join the community of researchers to share your own resources if you have. And don't hesitate to stay updated by following our social media channels on LinkedIn, on X, and YouTube. So thank you once again for your participation, and I look forward to seeing you during our next session. Goodbye.
Thank you. Bye, everyone.
Thank you.
Bye-bye.
Bye-bye.